Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with our Friday Afternoon Hangout. I am going to need you guys to pour yourself a nice big mug of iced coffee, because we are live, and I am going to need you to buckle up for what might very well be our most exciting Friday afternoon hangout ever. Hey, I've got a surprise for you guys today, and I see a lot of you guys are tuning in. We've got Ohio, Tech Teen, always good to have you. Manuel, one of our regulars. Hillary from Kampala, Uganda, welcome. One of my favorite places on earth, Uganda. S Labs, okay. Ohio. Sridhar, welcome. Steve, welcome. Omar, welcome. D Johnson, glad to have you. Florida. Luke, hello. Michael, Omar, Motion Tech, you guys, it's great to have you here. Electrotech, we've got Devendra, Muvedi, VJ. Man, we've got a lot of people coming on here. This is going to be a great live stream. Hey, you guys, anybody going to guess what my surprise is for you today? Anybody? Anybody going to guess? Hey, we've got ShuttlePod 1, Anthus, Shell. All right, we got a crowd coming in already. Anybody going to guess what my surprise is for you? No, not a free 3D printer. No. Okay, Jonathan McGee. Hey, Jonathan, I know he's one of my students, and so I'm glad you showed up, Jonathan. Welcome. We've got a cool surprise for you guys today. Oh, let's see. Michael Graves guessed that we would have Dusty on. How could we manage to get Dusty? That man is a legend, okay? We're going to build the jetpack. Luke, no, I am not quite ready to do the jetpack. Okay, you guys are kind of getting clever in your guessing, so maybe I should not stretch it out any longer, and maybe I should reveal the big secret for you guys. Okay, I want you to welcome to the program the one, the only, the man, the legend, Mr. Dustin Franklin. Welcome.
Hey everyone, thanks Paul. That's very generous.
Hey, what should we call you? Should we call you Mr. Franklin, or how would you?
Dusty's fine.
Dusty's fine. Okay, well that is great, man. Welcome. It is such a privilege to have you here.
Oh, because likewise. Thank you.
You really are. You are a legend, because it's like I always wanted to get into artificial intelligence, and I could never understand it. It's just like I would go in circles trying to understand it. And then I watched your Hello AI World, and it was like, I get it.
Yeah, and I was the same way not that long ago. You know, it was like 2016, 2017. So I was trying to learn it and get into it myself, and just kind of built that tutorial out of those experiences.
Oh, wow. So how did you actually get into artificial intelligence? I mean, what was the path that allowed you to learn it?
Well, I'd been a long time real-time vision guy since probably around 2008 when I got out of school in robotics. And at that time, everything was, vision filters, imaging, kind of like OpenCV style. And that was before even CUDA was on the embedded side, so we were even doing things in OpenGL for like optical flow and tracking and things like that. Then obviously the whole DNN thing got really big, and things started migrating over to that. But even before the time of TensorFlow and PyTorch and some of these more approachable machine learning frameworks, it was quite more difficult to get in there. We always used to say you need like a PhD or a master's just to understand what was going on. But I think the whole community has made big strides in, making it easier and more approachable for everybody to use.
Oh, wow. How long have you been at NVIDIA?
Since 2015. But before then, I worked for General Electric, and we made embedded GPU cards that would go into robotics and embedded applications. So I've been a partner of theirs since before then. But then when the Jetson came out and they started doing, embedded modules and dev kits, then I came over.
Is NVIDIA as cool of a company to work for as it looks like from the outside? I mean, it really looks like
it's
a great
totally
place.
awesome. Yeah, I've never been happier than at a place like this, and everybody is super sharp and has their own niche that they're experts in, and everybody works really well together.
Yeah, it just seems like one of those places with a culture that is just kind of like a can-do attitude, and it just seems to me from the outside that it would be a really slick place for people to work.
Yeah, we call it speed of light, basically, removing any roadblocks that might slow us down. And, we always have very hearty and healthy debates about everything to, deliver the best products and support to the developers. And because at the end of the day, we're developers ourselves, just like everybody else.
Yeah. Well, kind of like from just a normal guy perspective, the thing that I noticed that to me is really unique about NVIDIA is you guys actually are on your forums and you actually answer the questions and you're actually kind of nice to people. And so many times, like, it's like I don't just go ask a question until I've really, really tried to figure it out. But you go somewhere and you ask a question and then they just slap you in the face a few times. And, on NVIDIA, every time I put a question on the forums I've gotten, not only did I get a response, but I got a response that resolved my problems.
Yeah, well, firstly, we have like a really awesome community, and they help out a lot with the responses. So it's not just us on there. And at the same time, we really strive to get back to everyone as soon as possible. Probably because, we understand what it's like when you're running into a problem and you just like don't know and you need help and you want to solve it as quickly as possible. Maybe you have a deadline or probably it just bothers you,
Yeah.
So, we always try to deliver the best service that we can. It's not always possible to fix the issue right then and there, but we always do take feedback, file internal bugs, and try to get it fixed in the next Jetpack release or whatnot.
Yeah, yeah. Well, that's great. It's much appreciated. Well, I guess kind of like I got into the whole business with the Jetson Nano, and again, I ordered my Nano after I saw your little thing. Like, I can do that. And, okay, I did the little 10-line program, and then I did more, and I did more, and I did more, but I was able to get that early success, which then gets you pumped up to keep going. But then after that, then I got the Jetson Xavier, and that is like, it's kind of like having a Ferrari and a Lamborghini in your garage. It's just really
that little
pretty
Xavier
cool.
NX is awesome. Yeah. It's awesome. My whole desk is filled with like all the Jetsons, and yeah, I use mostly the Nano and the Xavier NX these days.
Well, kind of like, what would your perspective be on like the future direction? Like, give us a little insider's view of the direction that NVIDIA is going as far as these single board computers and these things like the Nano or the Xavier that seem to be a little bit more friendly and open to the home users.
Sure, yeah. Well, and we try to be as transparent as we can with our future hardware roadmap. I think if you just Google Jetson hardware roadmap, we have a page that shows a rough timeline of what we plan to do. And things have kind of converged around, there's the Nano form factor and then the full AGX Xavier form factor. So on the Nano, we have the Nano and the NX. And on the full AGX Xavier, in the future, we've already announced that there will be this ORIN chip. That's the next SoC. And if you Google NVIDIA ORIN, there's some high-level details about what that involves. It's basically the next generation of the Xavier SoC. So we, will continue innovating and adding more compute into the chips, improving, GPU cores and all of that great stuff, coupled with all of the great software libraries that NVIDIA provides, which is really what sets it apart and makes it all work, is that Jetson can run all of the same CUDA libraries like cuDNN and TensorRT that you would get on a PC or cloud platform. So it's unlike other embedded systems where it's a disparate architecture from the cloud to the edge device. And that's all because it runs CUDA.
Yeah. Well, I mean, even for me, it was just exciting to get the Xavier and to find out how transparent it was to go from the Nano to the Xavier. It's kind of like I didn't have to really learn hardly anything at all. All the stuff I developed on the Nano ran on the Xavier just way faster.
Yeah, it's essentially identical Jetpack build. It's just a different underlying SoC, which is most people would never really see those details unless you're a kernel developer or whatnot, like Linux kernel stuff. But yeah, since it runs all of the same libraries, there's typically very little that you would have to do to migrate in between, which makes it nice because then if you actually want to deploy this into the field, you can pick and choose your size, weight, and power profile. In embedded world, we always called it swap C, size, weight, power, cost. And those are kind of what navigate your decision to what module you might deploy in an end product.
Oh yeah, well that makes a lot of sense. Well, Dusty, you guys talk a lot about edge computing, and you know, again, a lot of times in artificial intelligence, we throw out these words, and maybe not everyone knows what that means. And so, probably most of our audience here are guys coming from the Arduino, probably interested in artificial intelligence. Maybe you could kind of give the beginner a little bit of an idea what you guys mean when you say edge computing.
Sure. Yeah, edge at its core basically just means having the compute out there in the field, or if you're building a little smart home device or gizmo or robot, the compute is actually there on board the device as opposed to in the cloud or being offloaded to another system. Edge has also grown to include on-premises servers or other small computers that you might have in a location, let's say on your factory floor or somewhere other than the cloud. And the reasons for having edge in the field are, primarily latency. If you're doing like a self-driving car or a robot, you can't take a round trip back to the cloud and, expect to, not crash into the wall or be safe. Other things are typically bandwidth and connectivity. There's lots of areas where you might be in a Wi-Fi or LTE dead zone and not maintain a good connection to the cloud. And another important one that's often looked over is security. You don't typically want to transmit the raw data stream all the way back to the cloud. So we see a lot of people that they cleanse the stream. They might blur faces or license plates or other things that shouldn't be transmitted back to the cloud before that data is archived. And probably the final one is that essentially it's a smart compression device. You might take a 4K video stream in and then just output the metadata of what that entailed, like there was this many objects detected or things like that. So you go from many megabits per second down to a couple kilobits per second.
Okay. Well, one of the really exciting things to me about what you guys are doing on the edge is the GPIO pins, because kind of like in addition to all the things you said, I then have an ability to interact with the world around me. So I see something and then I analyze it and then I do something based on what I see. Let me show you a quick little demo that I'm working on here, kind of with what you can do with those GPIO pins. Let me see if I can call this thing up. Let's see, I need to give me just a second here to... There it is. Okay, so you can see I have the Xavier here, and I have two of the Raspberry Pi cameras, and I have them on little pan tilt servos. And so
nice. Those are cool. Those are like little micro servos.
Yeah, and one of them, and then if you look at the screen, you can see that one of them, one of the cameras is tracking a blue pin, and the other one is tracking the red pin. So if I move it, it will do whatever it needs to keep the pin in the center of the screen. And so this is kind of like what I'm thinking about these GPIO pins, that it sees the pin, it boxes the pin, and then it takes action to keep the pin in the center. I can do the same thing with the pink pin, that as I move it, that pan tilt will move to keep the pin in the center.
Well, that's awesome. The range on those pan tilts is really quite good as well.
Yeah, and those little things, they were like $20 each, and so they weren't bad at all. Just to have kind of a quick little demo. But on something like this, the artificial intelligence part of it isn't very sophisticated at all. You're just using OpenCV and tracking on a color. But if you can do that, then you could go in, you could do face recognition, and you could track a person, or you could do your inference library, and you could track on an object of interest, and instead of pointing a camera, you could point something else. So all of a sudden, when you guys open up those GPIO pins, it just really opens up a whole world of possibilities as far as kind of like projects that you could do.
But really, the whole point of the DNNs is you can retrain it on whatever you're looking for. If you want to make like a fruit picking robot that picks strawberries, you can just go train your model on that, or whatever source material you're trying to do.
Yeah, so that is just pretty darn exciting. And we talked a little bit earlier, I'd actually gone through your tutorial on the, what do you call it, the transfer learning or the retraining?
Right.
Yeah, and I was able to retrain one of those standard models on recognizing single board computers. And I thought that was just really cool that sitting here at home as just a normal guy, I could actually be, in effect, creating a network that did something exactly what I wanted it to do.
Yeah, it actually takes less data than most people would think just to get like a basic proof of concept up. Generally, a couple hundred images or even less sometimes. Now, if you want to make a production model that's like 95% accurate or more, then you would want many thousands of images. But it doesn't take much to get started and to make a little camera demo out of it.
Yeah, and kind of like in going through that, so I'm learning from you, right? I'm learning as I'm going, and I can see that there seems to be sort of two different things. There's the image recognition, and then there's the object detection. And like image recognition is you got sort of a simple picture with the object in it, and it tells you what the object is. To where your object detection can look at a complicated thing like a room and can pick out a lot of different stuff and sort of identify a lot of different stuff at the same time.
And then there's also semantic segmentation, which combines the classification with the detection, kind of. So instead of performing classification on the whole image, it does per pixel classification, which is really useful for like labeling the road, or it's called free space detection, or other per pixel type of things that you might want to do, as opposed to the more granular bounding boxes. But that's in the repo as well.
Okay, yeah. And you're right, and I played around with that a little bit. But kind of where you've gotten me to this point is that I can train or retrain or transfer learn an existing network to do what I want for kind of like the image recognition. But what would be the path for me, or is there a path, or am I just too simple of a guy to imagine what would be the next step for me to be able to kind of retrain the object detection where I could find an object in a more complicated scene?
So I just recently did the tutorial for retraining your own object detection network using PyTorch. So Jetson's great because it can run the full frameworks on board, which means you can even do training right there on board your Jetson, where normally some other cloud system or PC would be required to do it. And now you can even retrain the object detectors on that. And in the tutorial, the data set, it starts off first, you retrain it on the Open Images data set, which I think has like 900 different, it might be like 600 different object detection classes that it supports, which is a lot. So you can first pick from those, and it'll download all the data for you, thousands of images, what have you, and then you can retrain it and get used to the workflow. Then you can actually collect your own data, and object detection typically does take more data than just classification. So it might be more time consuming to do, but you can make your own model for detection purely based on your own objects that aren't in data sets that are already out there.
Okay. Well, let me kind of tell you, I'm going to have to look into that, because let me kind of tell you the thing that is going on in my head that I'd like to really like to try. Like, if you look at these little pan tilt servos, I have one that's like this big, like a really big pan tilt servo. And what I'd like to do is I'd like to try to make like a non-lethal response to something like a school shooter. Like, imagine putting an airsoft, a paintball gun on it, and if this thing saw a guy with a gun, it would pelt him in the face with like 15 or 20 paintballs a second. And that's not going to incapacitate him, but it's certainly going to affect his aim. And so kind of thinking of a non-lethal response to a situation of a person with a gun in a school. And so to do that, though, I couldn't do image recognition. I would have to do the object detection. I would have to have the system understand that there's a person in the room with a gun.
Yeah, I think sometimes you just got to be mindful of the ethics behind, even if you intended for good, somebody could take that and reprogram it. So certainly there's nothing out there that would make that infeasible, but just got to be careful how you approach things as well. In general, we like to use AI for good or humanitarian like applications.
Yeah. Yeah, and like what I was thinking is that you would stop a person who was, you would stop a person who came in the classroom to, to harm people, and would there be a way to do that? Because kind of the challenge in a school situation is that by the time someone responds, a lot of damage can be done.
Yeah, certainly there are a lot of challenges how you approach that type of problem and solve it. But I think the bigger theme is you could use AI in a variety of means, and it could be useful just to be mindful of how you apply it.
Yeah. Okay. So Dusty, how did you get started in AI? Were you trained in AI at the at the university, or did you kind of pick it up as you went along?
I just had a general computer science degree, but I did study graphics and computer vision, and computer vision is still very much AI as well. Your little expo marker detector, even though it might be a simpler type of AI, it still is an AI of sorts. Computer vision, deep learning, machine learning, they're all under that umbrella, right? So at the time that I was in school, the deep neural networks weren't on the scene yet, but I do remember in high school, like for this one science fair project, I did a neural network based text recognition thing, and like nobody understood it because it was just at like a high school science fair. But that was back in the days of the MNIST, which was one of the first machine learning data sets for optical character recognition that is still widely used today for introductory tutorials and stuff. So that was actually my first exposure to neural networks and things like that.
So you had some experience in this area before you went to work for NVIDIA.
Yeah. I was heavily into computer vision and robotics before I came to NVIDIA.
Okay. So let's see, we've talked a little bit about the Jetson Nano and the Xavier, and kind of like we've talked about your AI world tutorials, and kind of like I've done a lot of stuff primarily in OpenCV just because it's sort of the easiest for me to understand. So like I'll use an OpenCV framework, but then I'll use your Jetson inference recognition tools, your Jetson inference libraries to do the recognition, but sort of operate within a framework of OpenCV. But that's just because it's kind of the simplest thing for me to understand.
Yeah, I've tried to make that easier with like the NumPy to the CUDA image type and things like that. The
and that's
uses NumPy arrays, and it's tricky in Python because you don't ever want to actually touch all of the pixels in Python. Like if you're using NumPy or OpenCV, those are just bindings into a C++ library or C library. So getting all that, the opaque image handles or data handles passed around and working between the libraries can be a little tricky, but I think it should be mostly turnkey now to pass them between each other.
Yeah, what I usually do is I grab the image in OpenCV and then I go to like CUDA from NumPy or whatever to go into the CUDA framework, your little line of code that does that. Then I keep the original image, I do the recognition, then the object detection or the image recognition, then you're using your utilities, and then I don't have to convert back to OpenCV because I kept the original image, but then I can box it or I can label it or I can use all of the really easy to use OpenCV things after the recognition is done. And I found in the things that I'm doing, it still runs really fast because I guess the hard stuff, you're absolutely using the GPU for using your libraries.
Yeah, most of the utilization would be in the actual DNN that gets run. So certainly OpenCV makes it easier to get started. And the way you're doing it also is a good illustrative example of how do you integrate that with other applications or interfaces and GPIO and stuff like that.
Okay. So you see, the good thing is there's a way to get started. There's an understandable way to get started. But once you get going, like how would you view the path to get the best inference performance on the Jetson? So we've got a path for guys like maybe coming from the Arduino to get started. But then what is the best place to end up to get the most out of these boards?
Right. So if you want the best absolute performance that you can do, it generally should be run through what's called the NVIDIA TensorRT library, which is an inferencing accelerator that's built on top of cuDNN. And TensorRT is what I use in the Hello AI World code underneath the covers. So if you're using that, you're using TensorRT even though you don't have to program it yourself, and that'll give you the best inference performance. Then on like the display and visualization side, if you're using OpenGL with CUDA interoperability, so the buffers don't get copied, or what we refer to as zero copy, that will give you more overhead to do multi-streaming and do lots of different inference streams at once, which is really the kind of the point of the DeepStream SDK. So if you're doing production applications where you have multiple streams, I think the Xavier NX can handle up to 16, and the full AGX Xavier can handle up to 32. Those are generally want to be done with DeepStream SDK, which is fully zero copy and can go all the way from camera ingest to inferencing and post-processing and visualization, or restreaming via RTP or RTSP without any extra memory copies in between. So that's what allows you to really scale this up to handle lots of different streams in parallel.
Okay. Well, let me, you brought up DeepStream, and let me ask you a few questions about that, because that, as I look on the NVIDIA site, that really seems to be kind of like a strong direction and a strong focus as far as where you guys are going in squeezing the most performance out of these boards. And I guess kind of me as not a computer scientist guy, I sort of took the webinar and the short course or whatever, and it was the one where there was the Jupyter notebook, and you go through and you kind of work some examples. And I went through it and I worked the examples, but after I was done, I'm just not, I'm not equipped enough, or I'm not enough of a computer science expert that I didn't know how to then go. I could run the demos and I could do the demo programs, but like if I wanted to do something like the little connect to servos and track, track an object of interest, I just didn't understand it well enough to be able to do that. And so kind of a question is, do you ever see maybe kind of like your Hello AI world, that would you ever consider doing something like a Hello DeepStream world, kind of a little more, a little more easy to understand path to allow some of us to start getting into the DeepStream?
Oh, sure, yeah. And we plan to do more videos, screencast style videos around using DeepStream. And a big new feature of the latest version of DeepStream, DeepStream 5.0, was that there's a new Python API for it.
Okay.
And we have a bunch of Python samples and tutorials on GitHub, and they're much easier to follow than the C++ examples, particularly if you're not a C or C++ programmer, which make it real easy to get up and running. And a really nice part of DeepStream is it's based on the GStreamer framework, which will allow you to bring in, a multitude of different inputs and outputs. And the OpenCV capture also can use GStreamer underneath for like bringing in RTP streams or IP cameras or CSI cameras or USB cameras or encoding video to disk or decoding video to disk, and there's like hundreds of different ways you can ingest and output data from it.
Oh yeah, well that sounds great. And my comments about the existing training is not a comment on your training; it's a comment on me. It's just.
We're always trying to make things easier and more approachable for everyone.
Yeah, and so I'm kind of eager to look into some of the Python stuff you've said, because it's just like, also it's like if I can see a Python example, I can figure it out, and then I can say, oh yeah, I see what they're doing. This is what I want to do, and then I could go out and start doing things. And it just it really seems like at some point those of us who got started on OpenCV really need to kind of move up to that next level.
Yeah, and there's even multi-stream Python examples with analytics. So it's pretty cool because you can take in multiple streams and then set up analytics and triggers for when certain thing happens. Like you detect the pizza guy is at your door, and then you send off a message to a server somewhere, and it like triggers your phone. Or that's just some example, but you can set up complex chain of events like that trigger actions to occur.
Okay, well,
all from Python.
I will definitely check that out, because kind of like I think in one of my reviews, again, I compared these boards to like getting a Ferrari, and I think most of the people, it's like they get their Nano, they run the demo programs, and then they kind of put it aside and don't go out and actually do anything. That's sort of like you're stuck in first gear. Well, going to OpenCV, I would say the analogy is you're getting to second gear, right? You're actually going in, you're writing code, you're making things do what you want them to do, but then you kind of reach, that's as far as you can go in gear. And to me, the next big step, kind of getting the Ferrari for us new guys into third gear, is to begin to kind of get ourselves a little bit away from OpenCV and see if we can start doing these things in DeepStream.
Sure, yeah, that's a good way to look at it. And certainly, if your primary objective is learning or making devices, there's absolutely nothing wrong with using OpenCV. But if you're, performance junkie, or, you want to run more complex processing but are being slowed down by the overhead, those other more optimized libraries and frameworks are there for you to use.
Okay, well let me ask this on the OpenCV topic. It seems like people have noticed that earlier on OpenCV was compiled with the CUDA enabled, and it seems like on Jetpack 4.4 it wasn't. Is that
I don't actually think it ever was compiled with CUDA enabled. And if it was a long time ago. So the heritage of OpenCV on Jetson was probably around like 2015. We had a version of OpenCV called OpenCV for Tegra, which had ARM, Neon, SIMD acceleration in the routines. That was CPU. Eventually, that got upstreamed into mainline OpenCV, and it's still there today. And that's the build that we provide now. And the build that we provide is newer than the one that's in the Ubuntu repo. I think Ubuntu ships OpenCV 3.2, and we're currently on 4.1. But yeah, unfortunately, we've never actually been able to enable the CUDA part for a couple of reasons. The primary one is if you were to actually run the tests, the test suite, a lot of them fail in CUDA. So it's not very well maintained by the upstream OpenCV maintainers. And for that reason, I believe it's in OpenCV contrib. It's not actually in the main OpenCV repo. So if they were able to fix the tests and get everything working, then in theory we could take a look at enabling it. But I don't think there are plans to do so. Although we still plan to keep providing the builds of it, and there are scripts floating around the community that will automatically rebuild it for you with CUDA enabled. I guess the bigger thing is that to use CUDA within OpenCV, it's a slightly different API. I think it's the CUDA namespace within OpenCV. So it's not all the same code, unfortunately. It doesn't automatically take advantage of the acceleration. Okay. For that, there are some other Vision APIs out there that are they have transparent backends to them, like OpenVX and VisionWorks. Those you can toggle between what device is on. And then the VPI or Vision Programming Interface for the Xavier, which can run the Vision Accelerator as well as CUDA and the CPU. So they're all kind of similar in what they do. It's just a matter of how the API is organized. And with OpenCV, I'm not sure you can use the CUDA acceleration from Python either. I think CV2 is CPU only. So there are some enhancements that would probably need to be made.
Okay, but it seems like that the kind of underlying DLib library and face recognition library do seem to run on the CUDA. And so like if I'm doing face recognition under OpenCV, I'm still getting like 15 frames per second doing like full face, not person identification, where you've trained it on people and it looks at the picture and it can see 7 people and it can box them and tell you who's who. And that's running at 15 frames per second. So it seems like that even if OpenCV is not CUDA enabled, if the inferencing libraries or the recognition libraries are, you can still run really quickly in OpenCV.
Oh, yeah. Okay. So it sounds like DLib is like exists outside of OpenCV as well. And DLib uses cuDNN and CUDA as a backend, which nearly all of the machine learning frameworks support cuDNN because GPU is like the go-to for training and on the inference side. So cuDNN is kind of a first-class citizen in nearly all the machine learning frameworks. And then you get that enabled for free in OpenCV. So yeah, that's great. I'll have to check that out.
Okay, well that sounds good, because at the end of the day, really what you care about is the performance. And if OpenCV is just doing some of the overhead stuff and the real heavy lifting is done by libraries like your Jetson inference libraries or those Jetson libraries, those will run really quickly under OpenCV, because OpenCV is just kind of doing the grabbing the frame and showing the frame part of it.
Yeah, I think it's important, especially when you're starting out, not to get yourself bogged down with a lot of those type of details, especially if you don't absolutely need the performance. And then over time, you can make optimizations and switch out the display back end or things like that. But when you're exactly right, when you're first starting out, it's good to, actually focus on the machine learning or computer vision routines or what the actual bulk of the program is doing.
Okay. Well, let me ask this. Maybe you could share with us a little bit about some of the latest news and highlights. What's going on at NVIDIA? What do you guys have coming out? I know that you've got a couple of new websites and a couple of new sections of your website and some new stuff coming out. Maybe you could tell us a little bit about that.
Oh, yeah, sure. So a couple of weeks ago, we launched the Jetpack 4.4 production release, and just recently launched the DeepStream 5.0 and Transfer Learning Toolkit production release. So those are out now. As I mentioned, it has Python support in it for DeepStream, and Transfer Learning Toolkit now supports a bunch of new models. And TLT, or Transfer Learning Toolkit as it's officially named, is kind of like the training corollary of DeepStream. So DeepStream's an inferencing framework, multi-stream inferencing, and Transfer Learning Toolkit is what you can use on the training side to make production ready models. Let's say you have multi-gigabyte data sets, or your data set's like 100 gigabytes and very complex models that you might want to prune or deploy very robustly using data augmentation. And we provide a bunch of pre-trained models through TLT, which are extremely high accuracy. So on the training side, you have TLT, and then that flows into DeepStream, and TLT uses TensorFlow and PyTorch, I believe, under the covers, and it's kind of a high-level wrapper, so to speak, around those. So it makes it really easy to make really high-quality models for. And also an important part of it, it does what's called pruning, or basically it's able to find neurons that are not actively contributing what's called activations into the result. And then it's able to remove or prune those neurons and make the model a lot smaller, normally multiple times smaller, which means it can be multiple times faster. So if you took a model that couldn't run in real time on the Jetson and prune it with TLT, then you could get real-time rates out of it. So it's a really super handy tool and a nice workflow.
Okay. Well, let's say that we had a guy coming from the Arduino and wanting to kind of get going on the Jetson Nano. Where on your website would be a couple of the good places for him to land? I think that if you just start, like just go to NVIDIA, it's very easy. You have such extensive resources, such powerful, extensive resources. It's a little easy for the new guy to get lost. And so a new guy, where would you send a new guy who was just trying to get started with the basics?
Great question, yeah. Because there are, with Jetson, not even to mention all the other NVIDIA products, there's thousands of pages of documentation and so many resources out there. I would probably focus on two sites. Okay, actually 3 sites. When you get a Nano, there's a little card that comes in the box with a getting started URL. Go to that if you aren't already familiar, and that'll show you how to flash the device, take an SD card from your PC and set it all up and get to the desktop. But then once you're at the desktop, you actually want to do some projects or learn AI. So where I would go then is we have this new page, the Create AI at Home page, that basically takes you through the flow of how do you get started. It even has some of your videos up there, Paul, about how you get and different types of programming, and then all of our different introductory tutorials, like the Deep Learning Institute courses that you were mentioning, that are really a great first exposure to what is machine learning, what's the workflow like, collecting data, training the model, testing it, going back and collecting more data. And then also has the JetBot on there, which is, you had mentioned that early on in the stream. It's probably one of the least expensive, fully autonomous, programmable robotics kits that are out there that runs the Nano. And you can train it to do road following or collision avoidance, object following, and then make your own autonomous modes from there, like waypoint navigation. There's lots of really cool stuff people have built on top of the JetBot, since it just runs Nano, and you can program it with Python or C++ or whatever you want. And then the Hello AI World tutorial in there too. So those kind of form like the holy trinity of tutorials for getting started with AI on Jetson. And once you've done those, you can go on and make your own project. So I would also recommend checking out this Jetson projects page. That there's a lot of community contributed projects on there that folks have posted to GitHub or made videos about, and it's an incredibly diverse and inspiring set of projects that are powered by AI on there. Everything from autonomous robots to smart home devices. There's a bunch of really awesome social distancing or COVID related applications that people have made. There's humanitarian ones for like the Clean Water AI project, and there's a bunch of these on Hackster as well. So there's really a huge wealth of projects out there that you can say, oh, I kind of want to do something like that. So you can take their project, fork it, kind of tailor it for your own needs, so you don't have to start from ground zero on everything yourself.
Okay, yeah, I think I'm looking right now at the Jetson Community Projects. Is that the page that you're talking about?
Yeah,
okay.
that's it.
And the neat thing about this, when I look at it, yeah, you've got your projects, which are great for people with a little more experience, but then also it looks like you are directly linking to the Hello AI world. And so even from this page, they can get back to your simple Hello AI world.
There's a couple of the curated ones at the top that we recommend just to get started on. And then the other projects aren't as much tutorials as they are actually implementing something. Like there's a bunch of these really cool pose estimation ones or gesture recognition, which some of these are like capabilities that you could then take and integrate in your application. Other ones are fully turnkey projects, like a smart doorbell camera, things like that.
Yeah, and it seems like a lot of them have the Python code. And so, like, again, those of us who maybe know Python and have gone through your Hello AI world, we can look at something like this pose detection and we can look at the Python code and say, oh, okay, I see how you did it. I need to get this library. And then I see that there's these 10 commands. And now you see, like, what I'm thinking is I could do pose detection, but then I could use that to give commands to something that moves something, like with some servos, right? It could detect where my hands were, and then that could affect something that was controlled by servos or stepper motors, or, kind of back to making those GPIO pins do something.
Yeah, absolutely. Folks like yourself have come up with some really ingenious and super creative applications for this stuff. And on my end, I like to work on the infrastructure and make tutorials for everyone in the community, like you and your followers, to go out there and do this awesome stuff with.
Okay. And so that is just trying to show people that is the, I'm going to look and see what I searched on to get there, because that's sometimes easier than a URL.
If you just Google Jetson projects.
Yeah. Yeah. I Googled NVIDIA Jetson embedded projects, and it was the first one. And you might be able to put something simpler than that, but for me, NVIDIA Jetson embedded projects brought me right to that page. And then the other one that you had mentioned was the...
thing worth mentioning is if you make your own project and you want it to be on that page, all you have to do is post it to the forums, and we review them every week and are happy to post your stuff on there. And we do a project of the month every month as well, where the winner of that gets like a free Xavier or GPU card or something.
Okay, well, I'll pass that along, because that kind of motivates people to get out and do cool things. And let's see, the other one that you mentioned was Explore AI at Home. And it looks like you've got some projects there as well that sort of show, okay, this is what you could do. And then you've got some really, really simple, clear, well done, straightforward getting it started, kind of getting it to first boot, flashing the card, getting it to boot. Then you've got the couple of videos I did on getting familiar with Linux and getting familiar with Python. And then it links to the Hello AI world, which is which is what, is sort of like once you get your Nano booted, that's kind of like one of the first things you want to do after you've gotten to boot. And then it's got the JetBot. So it seems like those two pages would be pages for a guy wanting to get in and wanting to learn. Those two pages would be really good starting points for them.
Yeah, we try to make it the flow of, coming in and just being interested in AI to, how do you get started? How do you learn the basics, all the way to, making your own DIY AI-powered device.
Yeah. Okay. So that is really, really exciting there. So we've looked at the Explore AI at Home, and then we've looked at the projects page, and that I would definitely recommend to anybody watching this video is kind of like the places that will allow you to get started. How could people more specifically follow you in the work that you're doing? Like, is there like a GitHub, or where would people go in order to kind of stay up to date with the things that you're working on?
Oh yeah, I mean my GitHub, I'm checking in stuff almost daily. The forums, I'm on there every day, answering questions. So you can find me there, and also LinkedIn. My full name is Dustin Franklin. So happy to
Okay.
connect with everyone, and we can message back and forth. But yeah, I try to be as approachable and out there as possible. So I'm always happy to chat.
Okay. Well, let me ask you a couple of questions of just sort of like kind of like how you got into all of this. You sort of talked about that you had done a lot of stuff and you were sort of working in the area, and then you went to NVIDIA and you more specifically started working on like the Jetson Nano platform. How did it like? How did you like? I'm thinking now there's a lot of high school kids that are watching this, and a lot of kids that it would be their dream to work at a place like NVIDIA. And so like what was the job interview like? Okay, you go in, and how did you get into this ability to get this really super cool job?
Well, in my case, I was fortunate. Actually, I already knew the team and then worked with them for a long time, made demos, and we did lots of trade shows and stuff like that together. But in the general case, that you don't need to have an insider track to get a job here or at other AI places, because these folks are very in demand for their skill set. So what might start off as just seeming really cool and interesting thing to learn, it's a incredible skill to have these days that can lead to great opportunities for you. And the best thing you can do is make projects and put them out there, put them on GitHub, make YouTube videos, and get exposure for yourself to promote what you're capable of and to really show. Because at the end of the day, that's what gets me most excited when I'm starting to work on people, is like, hey, these guys, they're out there, they're doing it just like we are, and they like to hack and tinker around, and there's nobody better than that who's like really interested in doing it.
Okay. Well, how about like as you were growing up, like were you a kid that was playing with computers and doing projects growing up, or did you get into this sort of stuff like later on in
No,
life?
yeah, I was always like a computer geek and doing programming from like a young age, but it wasn't always this real-time computer vision kind of stuff. I kind of got interested into that once I really discovered the power of NVIDIA GPUs. And I started off more on the graphics side, like making 3D game engines, and really into doing your own games. And that was in around like the 2000s era. So programmable shaders were like a big thing, doing your own 3D world demos, things like that. And then when CUDA came out, that was like a real big aha moment, because then I was like, well, I can actually harness this power and program it for whatever I want to do. And so it enabled even just a kid sitting in his basement with a little tower PC to have a lot of compute horsepower available to them, which led to some awesome opportunities.
Okay. Well, like a lot of young people, they just don't have that connection. Maybe they don't know somebody that's worked in the high tech world, and to them it would just be a dream that they don't think they could ever accomplish, that they might someday have a job like you have. I've got a lot of young people on here watching today, and a lot that follow this channel. What would your advice be to a person that's in high school or middle school who would dream of doing what you're doing today? What advice would you give them? What things should they be doing right now to be queuing themselves up to, one day be the next Dusty?
But that's a great question. I always can use help. I need like a whole team of people to help me out. So always happy to talk with folks. But what I would say, it's never too early or too late to get started. And this whole AI centric thing, it's kind of the new paradigm going forward. What might have used to been a 10,000 line code of like a state machine to do natural language processing or a hard coded computer vision filter is now, just a deep neural network. And learning the data science fundamentals behind that and the workflow of collecting data, training, deploying inference, those are the best tools in your toolbox to learn going forward. So, consume all the resources available to you. There's so much online training out there nowadays that you can get started with, and then go off and start making your own projects and training your own models. Because what I found is when you actually start training your own models is when you really learn a lot about the machine learning fundamentals and how do I prepare the data, and because you understand how the data you put in affects the output, and different things that you can do to make it more accurate, or prevent skewing the results and that kind of thing. And then just put yourself out there, like you, Paul. You're out there on YouTube connecting with others, and share what you've learned and teach others, because that teaches you a lot as well, which is what I really enjoy.
Yeah, and I think that's really good advice. And also, like, I really try to encourage the high school kids to go ahead and start putting things on YouTube, because a lot of times one of the things that really helps you be successful as an engineer or a high-tech person is it's not always the best programmer. Sometimes it's the guy that can really communicate, that can start advancing in the career. And so I think even as they're learning these things, to start working on some of those communication skills can also be something that is a big help to a successful career.
Oh yeah, and I think documenting your GitHubs, it might feel mundane, but it's a really great skill to learn technical writing, to be able to convey that information to others. And you never know who might be following your projects or actually trying to reproduce them or use them yourself. So it's always good to write a good README about things.
Okay. Well, let's see. We've got a few minutes left. Our time is kind of coming to an end, but would you have just a few minutes that maybe I could try to take a few questions from our audience?
Oh, absolutely. I'm happy to stick around. Yeah, I love taking questions.
Okay. And guys, let me ask if we would let the high school students start, because, we really, this is a real opportunity for a young person to talk to a real practicing guy in the mix in the middle of the, the big leagues of high technology. And so what I want to ask is that we pause and let the high school students or middle school students ask a question. And so I'm going to kind of open it up for questions from the young people. Okay, Braden is asking, is this the Braden I know, or is this a different Braden? Braden is asking, what kind of math does a career in artificial intelligence require?
Yeah, that's a good question. So we didn't really get into earlier, but there are different tracks within AI that you can follow. You can be the AI researcher who is making completely new deep neural network architectures, or you can kind of be a guy like me who's actually deploying it, training models, and then you can also be like an AI technician, somebody who's out there in the field testing the robots, maintaining the self-driving car fleet. So certainly if you're on like the researcher track, the PhDs and master students out there, they're heavy into the math. They'll know the equations for gradient descent, like the back of their hand. Me personally, I don't know, and you don't need to know. So it's not that big of a deal at all to understand the math. It's good from a programming practice to like understand how to, from Python, how to do those kind of things, but you don't need to be a calculus whiz to deploy this stuff and make it work for you.
Okay, so there's kind of paths for people who are more mathematically minded, and then paths for people who are a little bit more talented in the coding side. So that's good to know. Okay, yeah, I know Braden. He's one of my students, so it's good. Glad you tuned in, Braden. And then one of our really standout young people is Ohio Tech Teen. and I believe he is like a freshman in high school, and he just finished calculus this summer. So this young man is really, really, really
Wow,
on
yeah.
the path. I think he has got a Jetson Nano, and he's got a Jetson Xavier, and he's doing robotics. And so keep your eye on this young man, because I think he is really going places. But Ohio Tech Teen is asking, what was the hardest part for you in college?
Ooh, it was like the general prereq courses, like physics and calc, and because I mean I was real into programming and taking grad classes in graphics and applied math theory and that type of thing, which was like really interesting to me. It was all of the other like electives that they made you take that it was just like brutal to suffer through, and it was nice to graduate and then actually go on to work on what I was really passionate about.
Yeah, and I think sometimes it seems like some of those early classes, they're more trying to downsize the herd more than anything else. And
But
so,
I actually did it in reverse. Like I did all the stuff I was really interested in my first couple years. So then the last couple were brutal because I was just doing like the freshman courses as a senior, and I was just ready to be out of there.
yeah. Okay, let's see. I've got another question here. What programming language is needed for AI for industry perspective? So I think what they're asking is that if you really wanted a career in AI, what programming language should you be out there learning now?
Yeah, so the researcher types, they could work totally within Python or even just MATLAB, I've seen. But if you're interested in deployment or really want the absolute best performance, technically C++ would be a real good to learn just for actual, production ready systems, particularly on the embedded side. And over time, we see more and more Python applications actually being deployed for production systems. And that's because a lot of the Python stuff, it's just C and C++ underneath. And finally, the containers are really good to learn how to use too. Docker containers, because we use those on Jetson and embedded devices now too. And even before this year, I didn't use containers very much, but now I love them because it keeps your environment clean. And a lot of these machine learning projects and frameworks have so many different dependencies, and the builds are just fully automated for them. It's actually a really nice system to keep all of these different projects going at once without having to have like multiple SD cards,
Okay. Yeah, I think that's the other thing that if you ever had the chance that we would love if you could do a hello container world, because, containers, I understand how important they are and I see the power of them. That was another one of those that I had a little trouble just cracking the door on, that like I followed instructions. I had a container operating on my system, but I didn't exactly understand like how would I edit a program inside of a container? Just kind of like really, really simple things like that.
No, I'll have to do that because I do have a repo, the Jetson containers, and we've recently started publishing a lot more containers for Jetson. Like I maintained the PyTorch and ML, and I did a bunch of ROS containers, and I'm always adding new containers. And I had just recently learned it myself within the last year. But once you get the hang of it, it's really easy. There's Docker files, which is basically the script for building the container. And then at runtime, it's very useful. You can mount folders that are on your host device from within the container. So generally, like you'll have all the libraries and dependencies like PyTorch or dlib and all that stuff inside the container. So then you don't need to install it yourself. You can just pull the container. But then your Python script would typically be mounted from the host so that you can more easily edit it. You can also run the containers so that when you shut the container down, it doesn't throw away all your changes. You can commit changes to the container and edit it. But once you get the hang of it, it's actually really easy because it's not like a virtual machine where it runs in emulation, or it's literally just like launching a containerized process in Linux.
Yeah, and so that would be great someday to just see a little video of how you do that. What I ended up was just in this strange thing that like if I was outside the container just in my Visual Studio, then it wasn't recognizing all the libraries that were inside the container. But then if I moved inside the container, I didn't have a way to edit the program. And so it's really stupid what my problem was. But you would be surprised that I know there has to be just such a simple way to do it, but I couldn't edit a program, you know.
Yeah, it would be mounting the volume. And probably the nice thing about the containers is you can take the same ones that are on the cloud, and now that we've offered builds of those for the Jetson, make it very easy to migrate for. Like on PC systems, you don't, nearly everything is containerized. Some libraries and tools I've seen, they don't even offer a non-containerized version, just because there are so many dependencies and setting it up and everything. So now we're taking that kind of experience to the Jetson just to make it a lot easier. For example, it took TensorFlow it took like half an hour to install TensorFlow and all its dependencies on Jetson, but you can pull the container in 1 minute and then instantly use it. So it's a lot easier.
Okay, well that's good, and that's another thing that's kind of like I always have goals for myself. My two goals are I want to learn DeepStream and I want to learn containers, and then I kind of feel like I've gone from second gear to third gear. Okay, and those are the two things that if I could do those things, then I think I could do like way more than what I'm.
That's great. Yeah,
now.
I have, that sounds like a great idea.
Okay, let's see. I got a couple of more questions here. Thomas is saying that the container sounds like a virtual environment. I can see. I mean, there's sort of a similarity, but then the container is like a much more powerful framework. But
the containers, they fully run natively. They use full GPU acceleration, and it's not like a virtual machine in that aspect.
Mm-hmm. Yeah. So let's see. Another question from a high schooler is, what part of your job do you enjoy the most?
Oh, great question. It's definitely like interacting with the community, being out there on the forums, making tutorials that you guys learn and use from, and that's by far is the favorite part of my job. And then going on to see the projects that you guys make is spectacular.
Okay, so you actually enjoy your job.
Well, yeah, no, I always have my title has evangelist in the title because I'm really passionate about working with others and helping them, who then go on to help others themselves and make really cool stuff.
Okay. Well, let's see here. We're kind of coming to the end of our time. Let's see, one more question here. Jonathan McGee, what do you think is the most difficult part of learning how to code AI? And so sort of like when a high schooler or a middle schooler is getting into it, what do you think are like the biggest barriers or challenges that they typically are going to face?
If I look back to when I was learning PyTorch, for example, it was absolutely how do you start from nothing and code a whole script that trains like a classifier or detector? And the real answer is nobody does. They all consult the ones that come with PyTorch, and you get the workflow for that because there's a lot of stuff to set up. You got to load the data sets. You need to make the optimizer and the learner and set up the right loops to train it for the number of epochs and do validation and save the models, and it's like a lot of stuff in there. But the good thing is a lot of that work has already been done, and you can go in and tweak the existing scripts to do that, which is what I do personally. Like, I didn't fully author those PyTorch training scripts on the Hello AI world. They're attributed to the upstream PyTorch, which then I took and tweaked for this tutorial, and so using their workflow essentially. But then it's easy because basically you're just plugging in data and customizing your inference side of the application, which is much easier.
Okay. Well, let's see. I think we've got maybe one more question here that's a good one. Again, this is a young man, a high schooler from South Africa, and he is asking, what excites you the most about AI as you're looking towards the future and how this could just like really revolutionize the world? What are the things that are the most exciting to you?
Great. Yeah, another awesome question. It probably would be, autonomous robotics, what's coming out with self-driving cars, because really, we're tightly coupled with that type of technology. So we're really on the cusp of enabling full autonomy, and you would even start to see, delivery robots, particularly in the COVID situation that we're at. Those have been extremely helpful in urban environments. The deliver food or medicine completely autonomously. And a lot of that is just a bunch of different neural networks all running at the same time with path planning. And it's just been amazing where we've come from not even just a couple years ago. And then probably also on the natural language side, people might have seen the news about the GPT-3 model coming out a couple weeks ago, and BERT models, and those can be run on the Jetson now. So having an actual AI that you can talk and converse with, we're still not there yet for like the Turing test level of AI, but they're getting pretty smart in terms of what you can set them up with to answer questions about, and another couple years and you could have an actual interactive chatbot.
Okay, wow. All right. Well, Dusty, really, really, really want to thank you for taking your time out. I know you're a really busy guy, and to take your time to talk to us, kind of like us hobbyists and home guys and sort of us normal people. It really, really means a lot that you guys would take the time
Paul.
to do this.
I'm happy to, and you guys are awesome, and keep up the great work with what you're doing.
Okay, and if you guys ever have any announcements or ever have any news, you're always welcome back on here. Just give me a call and we'll schedule a time.
Sure thing, yeah. And don't everybody who's tuned in, don't hesitate to reach out, and we're always happy to connect.
Okay, well, I think I will wrap this thing up, guys. We had a great audience today. Appreciate you behaving yourselves as ladies and gentlemen on the chat, and appreciate all the good questions. And I'm going to wrap this thing up. Paul McWhorter from TopTechBoy.com. I will talk to you guys later.